Hello! In this video we will talk about the even and odd identities. We have 6 even-odd identities, and in the first row, because sine is an odd function, then sine of negative x equals negative sine of x. Cosecant is the reciprocal of sine, and it's also an odd function, and cosecant of negative x equals negative cosecant of x. Cosine is an even function, therefore cosine of negative x equals cosine of x. Secant is the reciprocal of cosine, and it's also an even function, therefore secant of negative x equals secant of x. Tangent is an odd function, and tangent of negative x equals negative tangent of x. And cotangent is the reciprocal of tangent, and it's also an odd function, and cotangent of negative x equals negative cotangent of x. Now, to understand these identities, let's take a look at the unit circle. So here we have the unit circle with the center at the origin of the rectangular coordinate system, and if from the positive x-axis we move into a counterclockwise direction, we will form a positive angle. For example, let this angle be pi over 6. Then the point that corresponds to this angle has the coordinates square root of 3 over 2 and 1/2. And notice that both these coordinates are positive. But now, if from the positive x-axis we move into a clockwise direction, we will form a negative angle. So this angle will be negative pi over 6. Then the corresponding point will have the coordinates square root of 3 over 2 and negative 1/2. So for this point, the first coordinate is positive, but the second is negative. Now on the unit circle, the first coordinate of each point represents the value of cosine, and the second coordinate represents the value of sine. So we can say that sine of pi over 6 is 1/2. So I will write that sine of pi over 6 equals 1/2. Now sine of negative pi over 6 is negative 1/2. So let's write that sine of negative pi over 6 equals negative 1/2. Then we can say that sine of negative pi over 6 equals negative sine of pi over 6. So the left side is negative 1/2 and the right side is also negative 1/2. And that is what we have in the first identity. Sine of negative x equals negative sine of x. Now the cosecant function is the reciprocal of sine, and cosecant of pi over 6 is 2. And that is because the reciprocal of 1/2 is 2. But cosecant of negative pi over 6 is negative 2. And now from these two expressions, we can write that cosecant of negative pi over 6 equals negative cosecant of pi over 6. And this is what we have up here. Cosecant of negative x equals negative cosecant of x. Now let's talk about the cosine function. Cosine of pi over 6 is square root of 3 over 2, and cosine of negative pi over 6 is also square root of 3 over 2. Then we can write that cosine of negative pi over 6 is equal to cosine of pi over 6. So again, cosine of negative pi over 6 is equal to cosine of pi over 6, and that is what we have here in the table. Cosine of negative x equals cosine of x. The secant function is the reciprocal of cosine, and secant of pi over 6 is 2 over square root of 3, and secant of negative pi over 6 is also 2 over square root of 3. So then we can say that secant of negative x equals secant of x. Now let's talk about the tangent and the cotangent functions. By the quotient identities, tangent of x equals sine of x over cosine of x, and cotangent of x equals cosine of x over sine of x. So to find tangent of pi over 6, we need to divide 1/2 by square root of 3 over 2. So tangent of pi over 6 equals 1/2 divided by square root of 3 over 2. Then if we cancel 2, we get 1 over square root of 3. Now tangent of negative pi over 6 equals negative 1/2 divided by square root of 3 over 2. And this will give us negative 1 over square root of 3. Then we can say that tangent of negative pi over 6 equals negative tangent of pi over 6. So what we have here in the table is tangent of negative x equals negative tangent of x. Now cotangent is the reciprocal of tangent, and it is cosine divided by sine. So if tangent of pi over 6 is 1 over square root of 3, then cotangent of pi over 6 would be square root of 3. And cotangent of negative pi over 6 would be negative square root of 3. So cotangent of negative x equals negative cotangent of x. I hope this helped understanding these identities, and now let's try a few examples. So here we will simplify two expressions using the even and odd identities, and above we have the rest of the fundamental identities in case we need them. Let's start with sine of negative x times cotangent of negative x. Sine of negative x equals negative sine of x. So in place of sine of negative x, we will write negative sine of x. Now cotangent of negative x is negative cotangent of x. So in place of cotangent of x, we will write negative cotangent of x. Then negative times negative is positive, so now we have sine of x times cotangent of x. Now using the quotient identities, let's write cotangent of x as cosine of x over sine of x. So now we will have sine of x times cosine of x over sine of x. Then sine of x will cancel, and the simplified expression is cosine of x. Now let's simplify the second expression. Tangent of negative x equals negative tangent of x. So in place of tangent of negative x, we will write negative tangent of x. Sine of negative x is negative sine of x. So we will replace sine of negative x with negative sine of x over cosine of x. Now these two negatives will make a positive. Then we will have negative tangent of x plus sine of x over cosine of x. But sine of x over cosine of x is tangent of x. So now we will have negative tangent of x plus tangent of x, and all this equals 0. So I hope you liked these two examples where we simplified trigonometric expressions using even odd identities. Thank you for watching.